Hello, I am Vlado from VideoLabs. In this video I will show you a few examples of how you can use the digital part of the VideoLabs calculator in order to calculate the required storage for the desired recording duration. This part of the VideoLabs calculator is pretty straightforward and not as complex as the visual part. The main parameters that need to be known in order to calculate your required storage is how many cameras you have in the system, what is the image compression used, and whether you are using the motion activated recording or continuous, and finally how many days of recording your client requires. As already mentioned in the introductory video about this version 2 of the VideoLabs calculator, we now also have calculation of storage required in minutes. This is a very useful calculation for when you need to export a short footage of an incident, for example, which typically would last only a few minutes and usually required when you want to pass this incident recording to the authority for further investigation. So I will show you how this is used as well. As in the previous version of the VideoLabs calculator, version 1, we also have the drive redundancy configuration calculation for when you decide to use RAID 1 or RAID 5 or RAID 6 hard disk arrays. Last but not least, we also give you a simulated picture quality for the selected compression using our latest test chart version 5. So let me show you the digital screen and the logic behind it, and I will also run you through some interesting cases using the hard disk drives and solid state drives available today in 2021. Alright, so I hope you can see my face as well as I'm explaining. So as you know, this is the visual screen of the VideoLabs calculator, the first one, which we explained already in the introductory video, but also we published a couple of different case studies which I suggested you see, because there are so many different things you can calculate actually with it. And to go to the digital part, you click on the menu and obviously select the digital. So this is the default screen of the digital application, and as you can obviously see here, the blue squares or rectangles are the ones where you need to enter parameters as per your system by choosing the drive capacity, which is shown at the bottom. This is only if, in case you are having quite large storage and you want to configure them in RAID configurations. So depending on which singular capacity drive you can find, there are different calculations for how many hard drives you would require. So let's say first we've got a little system of, let's for argument's sake, say 16 cameras. So first you can choose the number of cameras by either scrolling this window on the left, which says number of cameras. As we explained in the introductory video and other videos on this application, the version 2 allows you to enter any number you want in the windows by double tapping. So we will double tap on the number of cameras window, and we can enter, let's say in this case, for example, 16 cameras. So there's the first starting point. So you need to know obviously how many cameras you are calculating for. Next is what video compression or image compression you are using. Most common these days in CCTV, we use video compression, which means we are going to enter how many megabits per second each camera produces. 4 is very typical for H.264, which offers quite good quality for HD, high definition, 1920 by 1080 pixels. So we will leave it, let's say, at this stage 4 megabits per second. However, even though this is shown as H.264 streams of good quality, nothing stops you to enter any compression you want. So even H.265, which is more modern video compression, you can enter by just simply knowing the very basic rule of thumb that for the half of the amount of a video compression stream of the H.264, H.265 gives you the same video quality, more or less. So in that case, like if you set your camera to record in HD at H.265, most likely you will go here to 2 megabits per second. So let's now go back to 4D because I just want to show you something else as well. So let's put it back to where it was. And let's say now we are having a system of 16 cameras around, let's say, a business site, where if you want to use a so-called motion-based recording, we need to know what is the percentage of motion in that area during 7 days, let's say. And for that reason, you enter, or you can enter, any percentage here up to 100%. Now, if you don't do that, the system basically assumes that you're recording permanently or continuously. This is what I would use most often these days, because hard disk capacity is not difficult to find. But in case you want to save on the storage, or perhaps you want to extend the recording to more than what the hard drive capacity offers, you would turn on motion detection recording, which most of the cameras or NVRs these days offer. So that requires you to guess, to have a very good guess of what is the percentage of motion in a place. There is no accurate and precise estimate here, because this is only an estimate by you talking to the customer. So just give you an example. So let's assume this is a motor mechanic shop, business where the owner repairs vehicles, cars. Now, most of them would work at least 5 days a week, maybe 6. Some of them would work 6 days a week. Now, they usually would be open in the morning from, let's say, 7 o'clock. At least that's the case around my place. They open usually about 7 o'clock and they close, let's say, 4 p.m. If you assume that nothing happens before and after, then you find what is that percentage in the day, imagining that every camera looks at the area that has some activity. So let's go worst case scenario. So what we would do in that case, I'll need to turn on the calculator so I can calculate for you if you want to be sort of more accurate. So from 7 in the morning up until, let's say, 4 p.m., which is 16 hours, that is actually 9 hours during the working day. 9 hours as a percentage of 24 hours. So if I divide 24 by 9, I get about 2.67 times. That means in the workday, out of 100% time, in the 5 working days they have, if I divide 100 by 2.67, I'll get about percentage of about 37. That's about 37% activity in the working days. Now, let's assume they're working 6 days, not 7. That means we need to deduct again 1/7 of the working hours of the 7 days. So this is only 6, and that can give you another percentage. So we calculated in this case 37.5% to be more accurate, if it was Monday to Friday from 7 a.m. till 4 p.m. But if I now assume that actually this business is open 6 days, so including Saturday, then 1 day in the week will be left out. So that means out of the 7, 6 are used. So what we are going to do now is, if we divide 7 days by 6 days, that is 1.16 or 1.17. That means out of 100% days of 7 days, if we divided 1.17, that is in percentage 85.5. So out of the 7 days a week, this mechanic workshop works 85.5 times of the day as a week. So if we multiply this by 37% that we had before, so if we multiply that by 37%, that will come down to 31.6%. So what you can say is that overall, so taking 24 hours into account, 7 days a week, if this business is open from 7 in the morning till 4 p.m., then I will have about 30.6% of motion activity overall. Of course, now we just have to think logically. Does that business employ cleaners that come, let's say, after hours to clean up the workshop? That can add another hour or so, perhaps. Do the cameras in this business look at outside, where you've got trees that are moving, which will trigger recording as well? And when you take all this into account, you may end up, instead of 31.6 accurately calculated percentage based on what we're assuming is being recorded by the cameras, you won't be very far off. Realistically, you get 40%, for example, estimated motion. So in such a case, I would enter here 40%. And let's say the customer wanted to have 30 days of recording. So clearly you just scroll this to 30 days. And the calculated storage for such a small system that has 16 cameras recorded at 4 megabits per second, which high definition will show you quite a good picture quality, will be close to 8 terabytes. So it's really not very difficult to record this small business for 30 days with 16 cameras with estimated 40% of movement. Now, today in 2021, my comments in regards to this is it's better to record in some businesses or in many projects continuously instead of motion-based recording, because in the past that was very important since we didn't have that much high capacity hard drives. But these days hard drives are not only larger capacities, but also they are much more costly effective. They are much lower cost, much cheaper, let's call it. So I would say instead of having 8 terabytes drive, and as you know in 2021, actually you can get 18 terabytes of drive in one piece. Like Seagate sells 18 terabytes, Western Digital I'm sure, and we will see later on there are some even larger hard drives, so we can calculate some other examples. But the point is, if I can buy that 18 terabytes of drive, then suddenly I can definitely go to 100%. I can go back to 100%, so continuous recording. I have just slightly more than 18 terabytes, right? So what I can do is I can either reduce the required days to maybe, because now we can enter manually, so from 30 days, the old calculator scrolling jumped to 3 weeks, 21, but now we can enter anything, let's say 25 days. That is less than 18 terabytes. How about if we enter 28 days, for example? Maybe 27 will be perfect choice. So let's enter here 27. Sorry, 27. Perfect. So I can guarantee to the client, if I record continuously, that means I guarantee everything will be covered that the cameras will see. He will have 27 days of recording. That may be acceptable to the client. Maybe he will insist on 30 days. It's up to you. But this is how you would use the actual calculator. Of course, you can use the other way. You can still go to 30 days, but you want to use 18 terabytes drive because you bought one already, perhaps with your DVR. Then let's reduce the actual video compression stream. Instead of 4, let's reduce it to 3.5. Many of the cameras will allow you to do that. Perfect. So we can actually use 3.5 megabits per second on each of the 16 cameras, record continuously for at least 30 days by having 18 terabytes of drive. Simple. Now we also offer here a simulated image quality in order to show you is this acceptable or not. I suggest you really need to do a real test on site because every image is different, but with the compression chosen, you may use the VideoLabs test chart simulation to give you an idea. So what happens is if I now double tap, so you can see the complete overall image of test chart, which looks quite okay, in my opinion. You can obviously zoom in to see the details. I don't see that many artifacts as much as I could if I go lower compression. So to compare, if I go back now to 4, you will see that the picture quality is unnoticeably better, but it is better. 4 megabits per second versus 3.5 will give you slightly better picture quality. And just to prove the point, if we now drop it down to, let's say, 1 megabits per second, or let's say even 1.5, in case we want to save extra or we want to record longer with the same hard drive. If I double tap here, now you start seeing artifacts. See here, like the continuous gradation of colors. You can see how the stepper appears. You can see the artifacts around the face, at even the biggest face. And if we want to apply face identification, which in this case will be probably somewhere this face is here, you will see that probably it's not a good idea to drop it down to 1.5 megabits per second. So this is the purpose of the test chart simulation. And the same can be used for when you're using H.265 instead of H.264. Like in this example, we assumed we are using H.264, and the simulation is made with actual H.264 compression. But you can still use the same thing for H.265 by just using a rule of thumb that half of the video compression stream at H.265 is the similar quality as H.264. So that means that if I chose 2 megabits per second in H.265, the picture quality simulation that you see is not of H.265. We didn't want to overload the application with too many examples. The point is, if you are putting 2 megabits per second in H.265, then the simulated picture of the test chart really should be seen at 4 megabits per second, which is using H.264. We only entered the samples with H.264 and JPEG to give you an idea. In any case, what I wanted to say that by checking the image quality here, the simulated image quality here, you can actually make a decision. Yes, I'm happy with 3.5 megabits per second at H.264. But if you say, no, I want to use H.265, then just halve it. So that means about 1.75, which is, if you want to calculate, let's go 1.75 H.265 will be the quality that we already saw. But now, because the storage capacity has been reduced, let's see how far we can go with the same 80 terabytes. So obviously 60 days is without any problems with the same hard drive. Okay, so that's the simple example of how you use the digital part of the Videolabs calculator. Let's now switch to image compression, and I'll explain a couple of things there. Now, I think everybody that has either got my book or maybe been on one of my seminars, or perhaps you already know that from your experience and knowledge, image compressions are two-dimensional compressions of what the camera produces, as opposed to video compression, which is three-dimensional. So the video compressions use time as a third parameter, so the first two being horizontal pixels and vertical pixels, while the image compression is two-dimensional, so it's only horizontal vertical pixels of each individual image captured by the camera. Image compression does not care, so to speak, of the time concept, which is why you can take as many as you want, but there is no saving due to the processing of motion prediction, which happens in the video compression encoders, where you're creating a group of pictures. If somebody wants to know more about that, obviously there is plenty of video footage you can see on Videolabs website, where we're actually explaining all these things, and that's part of the training, that's part of the, again, of the books if you want to read. But the point is that with image compressions, you've got only individual images. So you just now need to know how many images per second do you have with the camera that you've set it up to stream, and what is the average frame size. Now, this is easily found for the particular camera by just simply exporting JPEG images from it when you're recording in JPEG mode, motion JPEG perhaps. And there is a very rough rule of thumb, which actually you can even determine through exporting JPEG images of your smartphone, let's say. Most people would have smartphone, and you know that if you take a photo with your rear camera, the back camera, which most likely typically would be 12 megapixels, we never export from the phone the raw uncompressed image. While with the professional cameras you can, in smartphones there is no point, because the image files will be so large for the very insignificant loss of quality when you save it as an image compressed by JPEG. And there is a rough rule of thumb. Again, it is not very accurate because it depends on the content of the image and so forth, but there is very rough rule of thumb that the megabytes produced by every image is about 1/4 of the megapixels that you have with that camera. So a 12 megapixel sensor will produce in JPEG, in decent quality JPEG compressed, probably about 3 megabytes of an image file size. And that is something to remember as a good guideline of what is the quality. And we obviously have made the simulation to be like that. So if we now go back to the same camera that we used video compression for and calculated the nearly 18 terabytes of storage for the 60 days, let's return it back to 30 days first. So we can, and just go back here to the 4 megabits per second like we had, so we can make some comparison. And remember, actually we reduced that to 3.5. This is just so you can compare. So this was, remember, for 30 days we needed about 17.3 terabytes for the 16 cameras continuous recording. So if we now go back again to image compression and to record with the same image quality while recording in image compression, the HD, which is 1920 by 1080, close to 2 megapixels. If you divide 2 megapixels by 4, that's about 500 kilobytes per image. But because we dropped this down to 3.5 megabits per second when recorded in H.264, I would say in CCTV we are squeezing as much as we can. So probably this needs to be about 300 kilobytes per image frame. So let's enter here 300. Okay, now if the project requires 25 images per second for real-time live streaming, obviously we have to enter, instead of 1 here, 25. So what we are getting here, this is something very interesting, and for the ones that are not familiar with the differences between video compression and image compression, see, we are getting here almost 300 terabytes of storage we require for the same 16 cameras recording over 30 days with 100% motion. And that means really you need so many more drives there. Now let's see the picture quality. So if we double tap, yes, it's pretty decent. This is a good quality, as I said. And for example, we say no, that's too much hard drive. So let's reduce it. Maybe you can reduce it down to 200 kilobytes. That is going to be slightly less quality, but we're already saving on almost 100 terabytes. That's a big saving in money. Picture quality, yeah, it's almost as good. Now again, I'm saying this is approximated, so you can't expect from the test chart to show you exactly the difference, because as I mentioned previously, every compression, whether that is image compression or video compression, every compression details and size depends on the content of that image. That's quite clear and known. So if you've got a plain white wall of the same HD resolution, the image of that will be much smaller in file size than if you've got exactly the same view, but you put in there, let's say, 10 people next to each other against the white wall, then suddenly you will see the image size may end up being from 100 kilobytes to maybe 300 kilobytes. So be aware of that. But anyway, the test chart is quite busy with details, which is why it's kind of a good approximation of real-time situation. So if we now, let's drop it down to 100 kilobytes per picture. The image now, I can see it's slightly now getting to the scenario that I don't like it to go to. But again, this is a simulation. So I'm just letting you know that this is the way how you can test some things. So let's say we are happy with 200 kilobytes per image. That's kind of good compromise. I mean, we always have in CCTV compromises of quality, but we still need 200 terabytes. So that's quite a lot. So for that reason, this calculator is very useful, where you decide which way you go. As I said, most people would go with video compression simply because it's so much more saving, and it's hardly any noticeable degradation in the latency, because the first and the only noticeable degradation using video compression is when you have latency and you have a camera that with a PTZ control, and when you want to drive it, then obviously you don't want to allow for latency more than 200 milliseconds. That's something I've explained in one of the videos about the standard. So if you're interested, please have a look at the video on IEC 62676, which actually talks about acceptable latency due to video compression. So video compression does introduce latency because of this group of pictures structure. The image compression doesn't, because I don't want to go through a full seminar through this example, but just so you know, the JPEG compressions, for example, are very quick. They don't require much mathematical decoding. That's basically any program can do it. Web browsers decode JPEG by default. You don't need to enter any decoders, any plugins. You may need to do that if you're using JPEG 2000. Some cameras offer JPEG 2000 as image compression, which is much more advanced than JPEG. JPEG being quite old and known to all programmers and all internet and digital devices, and it's free, but it's also fast. JPEG 2000 is better, requires slightly more processing power, but nowhere near what H.264 needs, and even further away from H.265, which is very demanding for processing. So this is the downside, let's say, of using video compressions. But once you have fast computers with a lot of GPU, video compression is always more valuable because it saves bandwidth, it saves storage. So that's the example that I wanted to show you. Today, in 2021, the typical 10 terabytes of 3.5-inch hard disk storage in Australia at least is somewhere from $400 to $500 to $600 maybe. So that would be very common, probably one of the most common hard disks that you will get today. So of course, as I said before, 18 terabytes are already available, and we actually can now enter, by scrolling you can enter up to 20 terabytes in a single hard drive. But if you double tap there, we've allowed now to enter even up to 10,000 terabytes. That is a 10 petabytes hard drive in one piece. Obviously this time will not be coming any soon, but I'm just saying that if you enter manually, you will have probably much more capacity than if you're scrolling. Let's now enter it as a 10 terabytes. Let's assume we are having a system and we want to record as much as we can in a one given computer chassis, which let's say I'll choose one that I will show you. This is a QNAP 12 bay 3.5-inch storage physical server computer that actually can host actual 14 3x4 14 hard drives. So what happens if we do that? How much we can record? So let's say we are going to increase now our 16 camera recording storage to put it back to 4 megabits per second. Let's, for the sake of calculation, we do H.264 at 4 megabits per second, which is quite decent picture quality like we saw for high definition. And let's see how many cameras we can do to go in 30 days to fit in those 140 terabytes. So if we just simply increase this, let's go, if we can't go there, we can enter manually. So the largest number of camera we can add here would be probably 100. Let's say for 100 cameras with scrolling. Otherwise, if we enter manually, see now we need more to get 140 terabytes. So now we double tap and enter, let's say 120 cameras. Yeah, so probably just a little bit less. So we can enter maybe 110, for example, 15 cameras, maybe even less. Let's make 112 cameras. So roughly 112 cameras we can record on those 140 terabytes drives if we buy capacities of 10 terabytes each for 30 days. It continues recording. Okay, but this is if we put them in so-called JBOD, just bunch of disk without any redundancy. Clearly, having so much recording, nobody in our industry will do it without really having RAID redundancy. Most often will be RAID 5 redundancy, which means you will need 15 of these drives, because obviously anyone can fail and you don't lose recording, to guarantee for 30 days of recording for 112 cameras. How about if we go now another little example the other way? How about if we go back to our original 16 cameras? Okay, and let's say with the same 140 terabytes that we may have in that one server rack, how long in days we can record? So obviously you just increase the days until you get over 120 terabytes. There you go. So 180 days will give me maybe a little bit more. Let's increase this 180, so double tap, make it 190 days, maybe even close to 200 days. There you go. So you can tell your customer that has 16 cameras, if we buy this rack and we put in there 10 terabytes drive, 15 of them if we want to be in RAID 5, we can record 200 days, which is for many people quite a lot. And that's how you calculate with the digital part of the VideoLabs calculator. I want to give you another little example that is available today in 2021, which obviously will change soon. A company called Nimbus Data has produced a 3.5-inch SSD 100 terabyte drive in one piece. Now, admittedly, this is very expensive today, but it is available apparently. And what I did here, and you can see it yourself because I'll put this picture, they are approximately $40,000 if you want to buy that one. But let's assume the money is not a problem for your system. And solid state drives are highly recommended by many, including myself, not because they are more expensive, of course, but because they have number of features that are really desired in security. First and foremost, they are much faster. Second, they actually don't have moving parts, meaning the wear and tear that is typical for hard drives will almost be non-existent. They may still fail from some other reasons, electrical, electronic, but certainly not from wear and tear. The electromagnetic optical drives, which majority of the large systems use these days, is very dependent on the three factors. Temperature, high temperature kills the hard drive sooner. Dust, which obviously accumulates there through everyday usage, and a lot of people think that hard drives are hermetically sealed. They are not. They've got so-called breathing holes. And also the vibrations or shocks. So for example, during the installation, physical dumping, the hard drive may damage it. Solid state drive doesn't have these issues, and even the temperature is much higher. From lower to much higher temperature, the solid state drives sustain quite a longer lifetime. My experience shows electromagnetic mechanical drive probably will last 5 to 6 years, because don't forget they are continuously reading and writing, reading and writing. Solid state drives I expect will last definitely at least double than that. My expectation is. We don't know yet because they are so new, but I use solid state drives on all my computers these days, and if you drop the notebook, it doesn't kill the whole lot like it used to be the case in the past. So anyway, let's assume now we've got 100 terabyte single drive, and let's say with this 16 cameras recorded at 4 megabits per second H.264 high definition, how many days is that equivalent to? So probably more than 120. Let's enter 140, probably 150 maybe. Yeah, nearly 150, which is, let's say, roughly about 5 months. So 5 months of recording on this single solid state drive of 16 cameras using 4 megabits per second H.264 high definition, and you don't need to worry then about JBODs or RAIDs configuration and so forth, because it's only one single drive. Now, of course, if you're using H.265, we said you can reduce this to half to approximately get the same picture quality. Then clearly this goes double, so we can now go probably 300 days, almost a year. There you go. So that's one way to use the VideoLabs calculator digital part. And let me show you now the minutes section. So if I tap here on the minutes, this section is made for quick calculations of people that have systems and they've got an incident, and that incident is captured on 16 cameras, for example, and lasts for 10-15 minutes. They need to know what size of USB flash drive they need to bring in order to copy that, back it up to take it to the police or give it to somebody else for investigation. So let's go back again to our typical 4 megabits per second H.264, let's say, high definition quality, And let's say we've got 15 minutes event that was captured on all 16 cameras. Or if we don't know on which one, let's say export all cameras. In our example system, we had 16 cameras. So let's export all of them for 15 minutes. So all you do is here really record in minutes, just enter 15. That's in minutes. So you'll need 7 gigabytes of USB flash. That is quite possible, easy to do these days. That's very cheap. So the purpose of the minutes calculator here is just to show you what size of USB flash you need in order to export the event. So there you have it. This is the digital part of the Videolabs calculator, and I hope you find it useful as much as I intended to make it. If you have any questions or suggestions, more than happy to listen. So thank you for watching again, and wishing you all the best.